Welcome guys, in this tutorial we'll be talking about the second chance page replacement algorithm. Now I'll explain you this algorithm by giving an example. Suppose there are 5 pages present in the cache which are A, B, C, D and E, and they are kept on the linked list and are arranged in the form in which they arrived into the memory. Like A arrived at time 0, B arrived at time 2, C arrived at time 5 and so on. And there is a pointer which is pointing to the head of the linked list. Now there is an extra bit which each of these pages, which is known as the reference bit or the R bit, which indicate that the page has been recently used or not. Like the reference bit R equal to 0 indicate that the page has not been used recently, while the reference bit 1 indicates that the page has been used recently, or you can say that the page has been used after the latest clock tick. Now suppose there is a page f that wants to suppose there is a page f that we want to refer. So we check for the page f into the cache, but since the page f is not present in the cache, it's a page fault. So we need to make room for the page f by evicting one of these pages. Now which page to be evicted is decided by the reference bit. If the R bit is 0, we directly remove that page and insert the page that we want to add. If the reference bit is 1, then we make the reference bit of that page as 0 and add that page at the end of the linked list. Now suppose that we want to insert page number f, then we will first check the reference bit of a. Since the reference bit of a is 1, we will remove that page from the head of the linked list to the tail of the linked list, making the reference bit as 0. So I'll erase this 1 and will add 0. Suppose that the page fault occurred at time 20. So this refers that the page A has been added to the linked list at time 20. It is referred as it is treated like a newly loaded page. Now the pointer is moved forward to B. Now the pointer points to B, and it checks the reference bit of B. Since the reference bit of B is 0, we can directly remove this uh, page from this cache and will insert the new page that we wanted to insert into the cache, which was F, at the end of the linked list. At the end of the linked list. Yeah, so this was page F, keeping the reference bit of that as 1. And suppose the page was inserted at time 21, and the pointer will be moved forward to C, and again it will check the reference bit of C, and this is how this algorithm will work. Now this algorithm has one advantage over the FIFO, which is it avoids the problem of throwing out a heavily used page. Like suppose A was in this case A was referred once, so it was given a second chance and was added to the end of the linked list. So it was used, so we didn't directly remove it, we added it again to the end so that we can once again refer it. Now this algorithm has one disadvantage also, which is if all the reference bit of the page is present into the cache is 1, it acts as FIFO. Like suppose if the reference bit of E and A were also 1, then it would have checked the reference bit of all, and suppose it would have checked the reference bit of C first and would have added to the end of the linked list, and then D, and it would have added D at the end of the linked list, and so on, and eventually it would have arrived on C again and would have evicted C. So this is how it would have acted like FIFO. So yeah, this was the disadvantage of second chance page replacement algorithm. And that's all for this tutorial. In the next tutorial we'll be discussing about the clock page replacement algorithm. Thank you.